bad. Okay, so today, 3:28, almost spring break, huh? So today, what we're going to be doing is graphing quadratic inequalities on the x, y plane, okay? Okay, write that down. We're going to be graphing quadratics, plural. Graphing quadratics, inequalities on the xy plane. Okay, so example 1. Let's take a look at it. Now, if we're going to graph this, there's a few things we have to remember. So I want to get a general shape. I don't have to have it perfect, but I need to put the parabola where it belongs. Okay, now first of all, I'm going to try and find the line of symmetry, which we've done before, okay? Line of symmetry, we're going to use x equals negative b over 2a, okay? Well, let's find that first, all right? So to find the line of symmetry, I'm going to use negative b over 2a, because it's in standard form. It is. So a is 1, b is negative 2, and c is 1, right? A is 1, b is negative 2, and c is negative 1, okay? So I'm going to go ahead and go, all right, I'm going to go negative 2 over 2 times 1, okay? Negative b is negative 2, so negative 2 goes here, 2 times a, 2 times 1, right? Okay, that's a double negative, so I got a 2 over 2, which is 1. So what I know is this, the middle, the very middle of the graph is at 1. Okay, so I'm going to put in my line of symmetry right smack down through 1. So the middle of my graph goes there, right? So the next thing I want to do is find the vertex. Brett, put your phone away, please. So if I want to find the vertex, here's what I know. And this is all these things that we've done lots of times. So hopefully this is not anything new for you because we've done this lots of times. So the vertex is 1 something. Has to be 1 something because the vertex must lie on this line. Has to, because if that's the middle of the graph, then the point I'm looking for has to be on that line, right? So 1 something. To get to something, I'll plug it in. Y equals 1 squared minus 2 times 1 minus 1, right? Plug it in. Let's see this. 1 minus 2 minus 1 makes a negative 2, okay? Okay, so my vertex is at 1, negative 2, boom. Now I don't need a lot. I have one other point. I really do. I've got my y-intercept, right? So my y-intercept is at y equals negative 1. Okay, the y-intercept is that, right? Okay, so I've got a point right there. Now, because I have a line of symmetry, I have a third point. You always need 3. So I have a third point right there. Okay, I'm going to draw my graph, okay? So my parabola is going to look something like this. Doesn't have to be perfect.
So the negative 1 means where your y-intercept is?
Yes. And let me explain even better. The y-intercept is where x is 0. X is 0. So if you think about it, if 0's in, you're left with negative 1, aren't you? Yeah. Okay, now, there's my parabola. However, this one's different. I want everything on this graph that's less than my parabola. I want all the points. Every single point that's less than my parabola. Now, less than my parabola is below it. Okay, does that make sense? So less than has got to be below my parabola, below the parabola, because I have y is less than or equal to x squared minus 2x minus 1. Okay, so I want everything below. Well, okay, ready? Watch. Ready? Just check it out. That point's below it, isn't it? Right?
Yeah.
That point's below it, right? Believe it or not, this point is below the parabola too. It really is, because the parabola keeps going up and up and up and up and up and up and up, right? Yeah, in fact, how many points are going to work?
Pretty much
All of them.
So how am I going to, I can't dot all of them, so what I do is I shade everything below. And this is weird because even up here it looks like it's above the parabola, but you're really below it here, right? So everything, right? everything below. All of these points satisfy the condition that they're less than or equal to the parabola. All of those points, let's shade it because it includes all of them. The decimal points in between, right? The negative decimal points in between, right? Every possible point in between, okay? Thumbs up? Does that make sense? Okay, now, example 2, we're going to shade above. So I did it on purpose so we didn't have to do extra work. It's the exact same parabola, okay? It's the same parabola. Because it's the same equation. You guys see the same equation? Do you guys see the same equation? So, yeah, you're way ahead of me like this. So I'm going to go to my vertex line of symmetry from above. Was at 1. Remember, we did that. Line of symmetry. Symmetry was x equals 1, right? Boom. I know my vertex. I did all that work from above. My vertex was at the point 1, negative 2, right? Right? I mean, I'm just doing the problem again. I don't have to do any work because I did it above, right? I did that on purpose for you. And then I also know I've got a y-intercept at negative 1, right? Because I have a line of symmetry. I have a third point right there. Reflects over, right? I reflect that point there, right? Now, here's the key. I want everything above the parabola, but not equal. I want everything above the parabola, but not equal. So we're going to do a dashed parabola. I'm going to make this parabola look dashy. How you like that? Nice and dashy. Because I'm going to shade everything above the parabola, but not the parabola. Right? I'm going to shade everything above the parabola, but not the parabola. And the way I show, and that's because there's no equal sign here. Everybody looking? There's no equal sign here, so it does not equal the parabola. So I show a dashy line. And now everything above the parabola, because it's greater than, so I have above parabola, because it's y is greater than x squared minus 2x minus 1. So everything, shade the whole thing inside, right? How's that? Shade above. So think above, not inside. So if you're standing, now here's the easiest way to do it. Go to the vertex. If you're having a hard time knowing where to shade, go right to the vertex. And if it's greater than, go above it. On this one, go to the vertex. Everything below it, go below, right? Now everything below is this whole region, right? It really is. It's kind of tricky to think that this is below, but it really is. Yeah, R2?
They're the exact, they're almost the same. Why is there a difference?
Great. 2 things that make it different. One is the inequality sign. This one says less than, below it. And this one says greater than, above it. This one does not have an equal, so it does not equal the parabola, so I get the dashed line. This one equals the parabola, so I get a solid line, okay?
Okay.
All right, you guys ready to turn the page? Not too bad, you guys agree? Not too bad?
Pretty easy.
Yeah. Okay, turn the page. Okay. Now, example 3.
Jacob.
I like example 3. You know why I like example 3? It's already in vertex form. So it's in vertex form.
Can't say it.
Vertex form. And I like vertex form because I know the vertex, first of all, the line of symmetry is x equals negative 1 because it's the opposite. Remember, it's got to be the opposite inside.
Why can't you multiply the x and the 1 by the negative?
You can't bring it in. You can't because you have to square it first.
Oh.
Does that make sense, Derek? So remember, it's got to be the opposite of the inside. Remember the silly little dance I do? Remember? Good. So I know it's not positive 1, but it's negative 1, right? So my line of symmetry is right here at negative 1. Okay. Okay, there's my line of symmetry. Right down negative 1. Now the vertex has to lie on that point because it's in the middle, right? Luckily, it's in vertex form, so I know my vertex is at negative 1, 2. Because I know that it's in vertex form. Negative 1, 2, right? Remember vertex form? Hopefully by now we've seen this plenty of times. So negative 1, 2. There's my vertex, okay? I need one more point. So let's find the y-intercept, okay? Now, Derek actually said something that's going to help us. He wanted to know why the y-intercept the way it is. So if x is 0, So y-intercept, let x equal 0. Okay, so if I let x equal 0, I'm going to have a negative 0 plus 1 squared plus 2, okay? So all I'm doing is this. All I'm doing is putting 0 in for x, okay? So all I'm doing, putting 0 in for x. All right, I can do that math. I got a negative 1 squared plus 2. Or I got a negative 1 plus 2, which is a 1. So my y-intercept is at 1. I got a y-intercept at 1. But I need 3 points. Am I going too fast?
So it mirrors.
So I plugged in 0 into my equation for x. Plug 0 in for x. Okay. 0 is for x. 0 plus 1 is 1. 1 squared is 1. Negative 1 plus 2 is 1, right? So I have a point on the y-intercept at 1. Now I need 3 points, but I know there's another point right there, right? You guys agree? There's got to be another point right there. And now I've got enough to graph it, okay? It doesn't have to be perfect, but I'm going to graph it. Now, dashed. Why am I doing a dashed line?
Well, because it's not equal.
Right, dash line. Okay, it says greater than, doesn't it? It says greater than, so I'm going to shade above. Now above's tricky and weird because it's outside of the problem. So if you go to the vertex, you're at the vertex, right? And you want to go above it. You'd go up here. You guys agree? Above vertex, greater than, I'd shade above, right? But it's this entire region is above the parabola. All of this is above the parabola. We get that kind of graph there, okay? Okay, we don't need to the journal. We're probably good. Thumbs up? Okay, let me stop recording. Now,